Hello, I'm David Piesse, and in this talk I'm going to go through some tips and tricks for working with spatial data in Laravel. I'm a Laravel developer, but for the majority of the last 15 years I've been a GIS developer, that's Geographic Information Systems, which is all about maps, data and spatial information. When I first started designing this talk, I began with a very non-Laravel specific approach, which was all about maps and the aesthetics and what to look for in a good map. Then I U-turned and focused very much on the code aspects of mapping in Laravel, but I realised that looking back on my personal experiences of merging Laravel and mapping is that you need a bit of both. So let me start with a story. It's a story about picking the right web mapping library and data provider for your web app. A web mapping library is the JavaScript code that displays your map on your website. The majority of developers will immediately reach for Google Maps, which can be a good choice, but there's also Mapbox, Leaflet, ArcGIS and OpenLayers, all of which might be suitable and better to display your spatial data. And this is the story of how I screwed up picking the wrong mapping provider. This video is from a UK mapping conference with thousands of attendees. Right at the start of the day, they kicked it off the plenary session and the technical lead commented on the increased usage of their platform.
Now you can't fail to notice there that there are two spikes at the end of this chart here. I wonder if anybody knows what those might represent. What were you doing between perhaps July and September last year? Who said Pokemon Go?
It was at this moment he knew. He f***ed up.
So what happened? Well, the reason I wasn't so happy was that on the launch day of Pokemon Go in 2016, I did a 24-hour map hack on my own for fun. I released it and it got picked up and featured in the technical online blog Wired that morning, and it went viral. I got far more traction than I had anticipated, and I was running around that day putting out fires. So on that day, I sent millions of requests to Esri, who is the biggest GIS provider outside of Google, and they did a valiant effort, and the cost me nothing. But I also had some Mapbox layers with extra data that cost a fraction of a cent every time they were requested. These layers in less than 12 hours racked up £1,000 on my credit card. Between explaining this bill to my wife the next day and the heart-stopping moment at the conference nearly a year later, this truly was my greatest success and most epic fail. So be careful with who you choose for your mapping provider and data. Google and Mapbox both cost money to serve you the map data that you require and can be very expensive at scale. If you have no money for mapping, try out Leaflet.js as a mapping library and OpenStreetMap for background mapping. Something I often come across on web maps is too much detail and too much clutter. So I recommend Marie Kondoing your maps down to the bare minimum. My first of these tips is to pick the right type of base map for your data. Where possible, keep your background mapping simple. A light, uncluttered theme is perfect for most applications. The only time to show or offer satellite imagery is where you need to zoom in on a reference background data set that you're showing, such as a walking trail or a mountain. Another example would be a solar panel calculator that uses the size of a building's roof. Even in a wilderness map that is showing the trails of a forest, it should be as simple as possible, focusing on the important details like the roads, the topography, the rivers, the high points, rather than the actual terrain itself. My next tip is to remove all the controls you can from that map. The zoom, street map, legend, base map, switching controls are all rarely needed. It's a vestigial hangover from maps of old when they were on paper, when users didn't know how to use online maps, and before the age of touchscreens. So keep your markers simple, however cool you might think a Taylor Otwell bobblehead looks. Clustering. When you've got lots of points on a map, you should try to reduce the amount of visible data, especially when it's visually close together on a map. Clustering is a capability your mapping library might have. It's certainly something to consider when picking a library. The default generic Google Map markers are often fine. People know what they are and they're familiar with them, but too many too close to one another and you have no clue how popular the bobbleheads are in Australia. So throw in a cluster layer to reduce the clutter. I also recommend constraining the scale you allow your maps to zoom in and out to. Take an example from Caleb Porzio's new super secret app Fisherman's Friend that I've built for him. Caleb wants to map the rivers he fishes and where he catches fish. He's mapped the river, but does he or any other user really need to zoom all the way out to the whole United States when looking at it on a map? Conversely, the scale and accuracy of Caleb's river digitization means the zooming in too close shows the lack of detail and actually muddles the overall use of this map. Allowing zooming in and out is one of the easiest ways to request more map tiles from your provider and skyrocket your usage bill. This next tip is on providing your front-end mapping library with data. Almost all mapping libraries can ingest GeoJSON, which is the open standard spatial JSON format. It allows you to provide spatial information as well as properties and even instructions on how to symbolize the features. Since Laravel 7, castables have made this super easy to turn a latitude and longitude or spatial property into GeoJSON. To show a single point on a map, this is a great way to convert a geo property into something the front end can use. Next up is getting GeoJSON for free. In MySQL and PostgreSQL databases, you can request a GeoJSON geometry object, which is part of a full GeoJSON response, without any back-end code. This is ideal when building complex spatial objects like polylines and polygons without having to manually hand build an object yourself. In Caleb's Fisherman Friend app, we could use a point to represent where a catch report was recorded. Let's have a look at how this could be implemented to store and return the location as GeoJSON. So we have a migration file. The location is stored as two fields, latitude and longitude. Quick side tip, the precision of your point should take into account how accurate you need to be. Precision is how many decimal points and accuracy is how close you are to the real value. GPS coordinates can be very precise, but the accuracy of the actual device recording them is very often no better than 1 meter. Within 1 meter, and you only actually need 4 decimal points. At 9 decimal points, you are down to the width of a few human hairs. Using the artisan command, we can create a castable, in this instance GeoJSON feature point, and we implement the get and set functions. This is what they look like out of the box. This is the code for our getter to build an object that represents GeoJSON. We can use the attributes value to access both the latitude and longitude rather than as just a single value. In this example, I'm only grabbing the ID property of the model rather than everything, but you could just pass through the whole attributes array from the model. We also need to account for setting the latitude and longitude. Assuming we receive a complete GeoJSON object back from the front end when there's an update, this code handles accessing the latitude and longitude nested within the object. The astute among you might have noticed that latitude and longitude are reversed. Another sub-tip here is always check the order. You don't want your data floating out in the middle of the Indian Ocean. Moving on into our actual model, we need to set up the cast. In this instance, it's called lat.long single feature. And then we have the front-end JavaScript. We don't need to go into specific detail about what it's doing, but this is Leaflet.js and it's one of the simpler mapping libraries to implement. This is the section where we pass in the report spatial field and we have it already cast to GeoJSON. And this is the end result. A map with a point in it. It's very simple, but with a few lines of code you have a repeatable and reusable means to get a GeoJSON object from your model and into the front end. Latitude and longitude, or a point. When starting to add a location to your data, your first decision should be whether you can store a point as two numeric fields or as a spatial geometry. Your choices are guided by which database you're using and if it has spatial types. If you're using MySQL, SQL Server, then you're in luck and spatial types are baked in. With PostgRE, you would need to add the PostGIS extension and enable it on your database, which is easy to do, and tools like Takeout allow you to do this out of the box. If you're using SQLite, then there are no built-in spatial types. You could, however, store raw GeoJSON. But why two fields? As a spatial expert, you would have thought I would always jump to spatial geometries and the complex options, but I often revert to latitude and longitude. The reason is it's the easiest to implement and can be done in any type of database. It can be used with the simpler queries and cover up to 80% of what is usually needed in the functionality of a web app. It's also usually the fastest to retrieve results in common queries, but a bit more on that later. Two numeric fields does limit the way you can query spatially. You can't determine the distance between 2 points or the nearest records to a location accurately. It's also unable to store complex geometries like polylines or polygons. Spatial fields are essential when storing complex geometries like lines and areas. It also allows you to query based on overlap, touching and distances. If you need this sort of functionality, you can take your two fields and generate a spatial point from them in a migration at a later point. Spatial indexes. Indexes can speed up your database queries massively in common situations, and you can index your spatial data too. This is how you add a spatial index. Super easy and built into Laravel already. This uses the GIST, that's Generalized Search Tree algorithm. At large scale, this could improve your query speed up to 200% over a non-indexed field. But if used incorrectly, it can have a negative impact. There are other index types and no way currently in default Laravel to generate these. In PostgRE, you could use SPGIST, which has benefits at certain scales and with certain types of queries. But you need a bit of raw SQL to actually create this index. But why even bother? Well, I ran some benchmarks on 10,000 basic records over a number of spatial operations, and the performance gain between GIST and SPGIST was never over 5%. This is one of those scenarios when you only need to dig a bit deeper when you're getting into the nitty-gritty of spatial data within your application. Nearby, but without using a spatial geometry. This is the real speed trick with a point location. You don't use a spatial field, you keep it simple with just two numeric fields, latitude and longitude. The caveat is that you can only query about what's nearby a location, and even then it's a bit rough. The idea uses bounding boxes, B-boxes, which are rectangles around a point, which databases can actually query super fast. And this is what it looks like, and it can be turned into a scope on a model as well if need be. This approach can take a nearby query of 100,000 points from 200 milliseconds to less than 10 milliseconds. This is ideal for getting nearby locations for an overview map without burdening the database with an expensive spatial query. It's very often that you don't need the precision that spatial queries give you, you just need the rough idea. With GPS, which is latitudes and longitudes, you're working in degrees and not meters or miles. So 0.1 degrees is approximately 10 kilometers at the equator. So your resolution is not as obvious, and you can't easily convert from degrees to meters, as where you are in the world, north and south or east and west, can change this. Sometimes you want to show many points on a map and not just one, as we previously have done, and a great way is to use GeoJSON again, but feature collections. To do this, you can make each individual model into a GeoJSON feature, and then these need to be wrapped up. Tim McDonald at Laracon AU 2019 spoke on extending collections, and this is how I've implemented it to generate a full GeoJSON feature collection from a collection of models. So what is the process? Well, to show a collection of models, we need to create a new class that extends a collection. Something as simple as this. We then add a GeoJSON function to it, which returns a structured object that represents a feature collection. It takes in the items and spits out what we want. You might actually notice a similarity in the structure of a single feature is exactly the same, but just wrapped up into a collection. Then we tap into the model itself in the new collection function and link it up like this. Now we've done this, we can replace a load of code that would have been in our controller. We used to iterate over all the reports and map them into features. Now it's a one-liner, and we have the same output as we have before, but we can reuse this GeoJSON collection extension in any of our models. It also allows us to prevent hard coding of properties into a GeoJSON feature in many places in our code base. Something I'm sure most of you are aware of is that photos can have EXIF data, that's metadata hidden within the photo file. Part of this could be the location it was taken, latitude and longitude again. This has been used for good, such as discovering where photos of lost people were taken, through to the hunting of foreign spies. In Laravel, we can access EXIF data of an uploaded file. You will need the EXIF PHP extension installed and active on your machine. And back to Fisherman's Friend, Caleb Porzio's awesome app, and here is a create a catch report form. This form uses Laravel Liveware to make it super easy to upload a file, such as a photo, to the back end. And this is the function that we have to save the data from the form. First, we get the path of the photo. In this example, we use intervention image to grab all of the EXIF data from that file. I've used intervention because they have a built-in method that makes it really easy to access the EXIF data. And finally, in this code, we call a method that tries to get the GPS location of a photo. I've separated out getting the location from the EXIF data because the location is stored in a weird way. It looks like a mess, and that's because the location is not stored as decimal degrees at 51.1234, but as strings of degrees, minutes and seconds. So you need to convert those into a decimal degree, latitude and longitude. Once we have this, we can then create a catch report record and save the latitude and longitude. But what if the photo doesn't have location information embedded? In that case, we could use the current location of the user's device instead. But geolocation is tricky. Only ask if you must. We all hate those pop-ups on random sites asking for your location when you haven't even got a reason to provide it to them. Getting a user's location is done in JavaScript, and it's a big power drain on a device. To save their battery, only get their location when they want it captured, when it's needed. Don't be tracking your users if you don't need to. In this code snippet, we're using Alpine.js within a HTML form. We've got two inputs, one for latitude and longitude, which are linked with Alpine to a lat and long variable. We've also got a button in there that will grab the user's current location when clicked. So report form provides all the Alpine context we for the form. We have our linked latitude and longitudes, and we have 3 functions. The first function, update current location, is called when you click the button. It first checks if you have geolocation enabled in your browser, and then it uses get current position to get the current position of the device when called. This takes 2 callbacks as arguments, one for success and one for failure. If it's a success, then we extract the latitude and longitude from the return position and update them in the form. This is about the most basic means to get a user's position in a HTML form. In a real app, you're likely to hide the latitude and longitude fields from the user and do it behind the scenes. A sub-tip here is to store the complete position object returned by the device in your database. This is in case you want to do more spatial analysis of the locations at a later date. It's really helpful to store the timestamp and the accuracy for validation. In addition, the speed and heading can be really useful to building tracks of users over time. My final tip today is to lazy load your map scripts and resources. It can take a Google Map implementation seconds to load up everything it needs, and if it's used in the lower half of your page, which it often is where the address is, it can make your whole page feel very slow and sluggish. Defer it where possible, or even begin loading based on the scroll position. We're not just talking about the JavaScript for the mapping library, but the tiles of data behind it and the data that's going to be shown on top. A map can make up to 70 requests just to show the initial map, and it can be hundreds of kilobytes, if not megabytes, in scripts, images and data. Also, if your map never actually moves, make it a static map image instead. Now, I said my last tip was my final one, but this one is about not using a map at all. You don't always have to display spatial data on a map just because it has that opportunity. A good example is with US presidential elections. The map looks pretty, sure, but it's misleading and actually irrelevant to the result of the election. What matters are the numbers at the top, which the map cannot display well. Without the numbers, the map is somewhat useless. But without the map, the numbers still tell you who won. So a quick recap of some of the points. Keep your maps simple, declutter them of all the controls you can, keep the base map as bland as possible and your data as simple but efficient as possible. Pick the right mapping library so you don't have unexpected bills in the morning. Use GeoJSON for transferring data between front end and back end. Lazy load your map if possible. Only get a user's location using geolocation if and when necessary. Use a bounding box query rather than a spatial query within to speed up your queries where it's a suitable option. And don't use a map if you don't have to. Thank you very much for joining me in my talk. That is all. I love the Laravel community, and any chance I get to give back, I really do enjoy. And I'll leave you on one final story. In my previous job, I used Laravel to help spatially map opium fields and the Taliban in Afghanistan, among other things. It sounds very odd. It was very odd. We used satellites and Laravel applications to find heroin. One of my projects involved sending survey teams out to the worst parts of Afghanistan. This is not something the normal developer has to do, but this was part of the specific project we needed to survey land along a new pipeline. I can attest that not only is Laravel good enough to be used in your application, but I've used it in life-saving applications with men on the ground in the worst parts of the world. Laravel has not only delivered the results, but it's saved lives and it's allowed people to go home safe at the end of the day. Once again, thank you very much and have a great Laracon EU.